Thank you, Michael. Hi, everyone. This is Huawei Yang. I'm an electrical engineer from Baidu, USA. And joining me today is Anthony Chen. And together, we're serving the point of contact for this power work stream under the OAI system group. So, Anthony, next one, please. So, to give a quick introduction to OAI system and the OAI power workstream. First, there's some previous work under the old OAI GDA group. So we published the UVB spec v1.0 and the OEM spec v1.1. And they are both published through the link posted. So as a successor of the OAI GDA group, we're currently, as Whitney and Tianyi already introduced, we're currently split into the work streams from the GDA group. So currently we're under the CLA, Contribution License Agreement. And for the power work stream, we're mainly focusing on the power delivery side of the OAI system. So this presentation is pretty much the introduction to the power work stream and a call out to everybody to join our work stream to work under the scope as listed. So first, we would like to provide the scalable OEM power delivery framework for OAI systems. So basically, we have different OEMs, they have different power requirements, and under the same or multiple OEM system, it becomes more challenging to provide the scalable solutions. That's the first thing we would like to address. A second one is we would like to have the reference PDB designs that with flexible conversion footprint. Basically, we have multiple and different VR solutions from different VR vendors, and they all have different form factors, have different footprints, and have different power specs, and it becomes more challenging to put or combine them, or actually have a I would say a universal or common footprint that can accommodate all different flexible conversions that from the different vendors. So that's the second challenge we would like to address. And third one is the interoperability of the OAI PDBs that is compatible with different OAI systems. So basically, we have different OEMs, we have different OAS systems, and it becomes challenging if we want to interchange with different PDB into different OAI systems. And the last one is we would like to define the specifications that can guide the industrial vendor collaborations. So those are the scopes for power workstream. Next one. And here is a general power delivery architecture for the OAI system. First, we have the bus bar or the power supply unit coming in as the power sources. And then we have the PDB. And the PDB has more active power conversion on it and serve as the main power distribution. And then we have the UBB and HIB that is getting power from the power source through the PDB. So on the left side, we have the 54-volt hot swap controller, and it will have 8 individual hot swap controllers for either different OEMs. And then if we have a 54-volt OEM, then we'll have the power delivery from directly from the hot swap controller to the OEM. And then if we have the 12-volt OEM, which is also supported by the UBB, and then we'll have the 54 to 12-volt intermediate bus conversion in the middle, and then to the 12-volt E-fuse, and then to the OEM. And on the PDB, we also have some low power standby VR that is powering the standby VRs on the UBB and HIBs, and also the fans. Yeah. Next one, please. And here is a general introduction to the UBB and OEM power requirements. We have the UBB and PB input voltage listed here. For the 54/48 volt, the UBB and PB will support minimum from the minimum 40 volt up to 59.5 volt. And for the 12 volt, we'll have the minimum from 11.0 to 13.2 volt. And for the OAM TDB, we have the symbol design power two different levels. The first one is the 58/54, 48/54 will support maximum 700 watts. And the 12 for the 12 volt, it will support up to 350 watts. And we have some OEM excursion design power listed here. This is coming from the UBB and OEM spec directly. And we also have the listed here is the INSPIR example design that is shown in the 2020 OCP Global Summit. And we can see the total power for this system is around 5,000 kilowatts. 5 kilowatts. Next one, please. And based on the previous design and collaborations, we have seen some challenges and limitations. The first one is the compatibility. First, we have the different power sources, 54 volt bus bar, and then we have the 48 volt power supplies. Second one is the we need to supply both we need to supply either 48 volt or 12 volt input voltage based on different OEM vendors. So that becomes a challenge if we want to make it compatible with two different power levels, voltage levels. The third one is different OEM vendors may require different EDP requirements, and to meet different requirements on the same OEI system become more challenging. And the second one is the scalability. As we can see, we need to support the entire OEM TDB range, which is 750 watts for 54 volt and 350 watts for 12 volt. And different OEM may have different power levels, and it becomes challenging that if we want to put, we either support the full range, and then we have the interchangeability from different OEMs. The second one is the variability of the power conversion solutions. As we mentioned before, we have different power conversion topologies, footprint, and form factors, and it becomes more challenging to have them put on the same board. The third one is the efficiency optimization. Based on different current and voltage levels, the efficiency may, optimal efficiency may lie on different efficiency curves. So we'd like to address that too. And the last one is the interoperability. So basically, we want a UBB and a HIB to be interchangeable in our OEI system. So basically, we don't want the one specific UBB and one specific HIB to be bonded to one specific OEM system. And with that said, we have some proposals later will be shown by Anthony.
Okay, yeah, thank you, Huawei, for going over the introduction. Yeah, as Huawei mentioned, the power workstream in the OEI group is rather new. We are still working on coming up with the detailed scope and also working on the various proposals. Based on some of our preliminary discussions, there's a couple of options that seem to be most popular amongst the feedback from the community. So just going over very quickly, the three options that we're currently considering is, of course, one that's more dedicated to support the 12 volt OEMs, right? Through something like an intermediate bus converter going from the 48 volt to the 12 volt. Option two, this one I think probably more straightforward since we can use direct conversion, meaning we just take the 48 volt directly from your bus bar or your PSU. And then deliver this to the OEM. Option three, so this one actually is interesting because it's currently not enabled by the OAI specification, but we do see there is an opportunity where we can actually enable people to use 48 volt OAMs, although their data center infrastructure or their rack topology is still on a 12 volt solution. So we want to also look into the opportunity of enabling a step up solution as well. So in the following slide here, just to go over a little bit more detail. So here we have option one. So what we're basically trying to think about is to develop a modular OAI PDB, right? So that's definitely one of our goals. And one of the things that definitely we're getting a lot more feedback on, and the things that we want to work with the industry is to figure out how to define the flexible DC-DC conversion footprint. So at a high level, as we mentioned earlier, we typically would have a 48 volt rack bus bar or a 48 volt PSU from the left. And this power would usually go through some sort of a hot swap controller solution. And the power would be then further distributed into the converter footprint that we mentioned here to eventually power the 12 volt OAMs. And also there will be some housekeeping power to also power any sort of POLs or PCIe switches or anything that you may need for the rest of the OAI system. And switching gears a little bit for option two, relatively simple, right? So basically, in this case, we can easily directly supply the power from the input source to the OEM while keeping majority of the PDB the same. And the third option that we trying to think about and seeing if there's interest in the overall community is to look at actually performing a boost operation to actually boost the 12 volt input to a 48 volt so that you can also utilize the 48 volt OEMs and not being restricted to only the ones that offer the 12 volt solutions. We think this is something that's pretty interesting because this does enable a lot more people to join into the community and also evaluate the various solutions that are available. So that is something that we're trying to consider as well. So going into a little bit more detail about the current scope that we have in our CLA, and of course we're still very open to feedback, and we're definitely looking for more opinion and membership from the community as well. But definitely with the things we want to do is to really standardize the input and output power delivery requirements. As Huawei mentioned, there's quite a wide variety of things that would really need to be consolidated into a spec to make sure that we are interoperable with the various type of OAI system. And of course, the other aspect is to look into enabling a power conversion topology agnostic footprint. So there's definitely a lot of great solutions out there, but one of the main challenges we do see is how do we actually put all of those things together into an actual design. So we really want to focus on aspect. And of course, there's always going to be some discussion around, hey, do we need isolation or not isolation for different type of rack power delivery systems? And, should we look into regulated versus non-regulated options? All those things, we want to make sure we cover when we talk about this flexible footprint. So to kind of just wrap things up, right, in the call to action slide here, again, we're still kind of a relatively new work stream, and we're really discussing a lot of these things rather live. So definitely we're looking for more collaboration on our existing modular OAI specs and also the PDB spec that we will be working on as part of this group. And of course, we definitely want to look into the additional use cases and considerations, right? Like the different topologies, a different type of maybe power trees that is maybe unique, right? We definitely want to see if we can incorporate some consideration around those use cases. And of course, we really want to encourage more on the industry alignment. We get a lot of feedback and question on how to really size up the solutions and make the right products to support this type of ecosystem. And of course, the fourth thing is we're always encouraging for greater community adoption in the OAI work group, and also looking forward to more contributions as well. So yeah, to wrap things up here, right? So between myself and Huawei, we're the main point of contacts for the work stream. So feel free to reach out to us. Otherwise, feel free to also subscribe to the wiki page where you can find the latest specification, and also join the mailing list where we also have a monthly meeting to go over various updates as well. So thank you everyone for your time.
Thank you, Anthony and Huawei. That was a great presentation. Thank you so much for the work you're doing in this new work stream. Hopefully some folks on the call will get involved and help you out with all the great things you guys are doing. Up next, we have Shiyong Li giving a presentation on Baidu's AI infrastructure. Shiyong, I see that you're on the call.
Okay, thank you, Matt.